Alright, so as promised, I am doing a video on trace tables for your review. Now, a trace table. A trace table manually runs a program to test the program, to see if it is working correctly. Alright, so we are testing the program you created. Trace tables are used with pseudocode and programming code. Now, before I go more into the trace table, I just want to explain the need for the trace table and how it is used within programming or what is programming. So, in programming, you have the user, you have the person who is going to use the program. We're accustomed to that. Right now, I am using Microsoft Word. That's a program I am using. So, currently, I am the user. But somebody created Microsoft Word for me to use and you to use. That person was a programmer. All right. So the programmer created the software, created the program for the user to use. So the user does not see all the code that is behind this program, right? I am just seeing the way to interact with the program. I am seeing whatever I see on my monitor. Okay, what I see on my monitor is maybe half or a quarter of what goes on with the program. The programmer would have written the code so that I see certain output, right? So the user will see certain output on their monitor. The programmer will also have input statements, and based on your prompt statement, the user would type in data. And anything the user types in, that shows up on the monitor. So the monitor, or what you see, what the user sees on the screen, is a link with the programmer. Okay, so again, the user does not see the program. The user only sees parts of it, only sees the part that the programmer wants them to see. Good? Good. Now, before the programmer gives the program to the user, the programmer needs to test it and make sure that the program is working correctly. And before the programmer even types the code on the computer, the programmer needs to write the code down and manually test it to see if it works. That's the trace table. So the trace table comes in when the programmer manually runs the program to test it on a paper. That's what I mean by manually. Once that is working, the programmer will then type the program on the computer and test it again and then give it to the user. So there are a few stages to testing, and we are starting with the first stage, which is using a trace table. So we're going to use a trace table. Again, it manually runs a program to test it and see if it works correctly. We use the trace table pseudocode and programming code. So any kind of written code. All right, now let's get into the trace table itself. So I have the instructions here, which were given to you, and I also have an example pseudocode algorithm program, right? So let's just look at the program first. It has algorithm example 1, store, we have a constant here, we have variables here, start algorithm. Okay, so this is the actual start of the program. Obviously, it says start algorithm. So from this point down, we we are going to test the lines of code. Okay, so the line of code, this is a prompt statement because we see you have a read. So if you have a read, which is an input statement, you need to have a prompt on top of it, right? So this, let me see if I could just get a different color pen. This is a prompt statement. Okay, this is an input statement, right? right? And then again, we see a read and a print. So again, that's a prompt. And oops, too much information. Um, right, and again, we have an input. Then we have, oh, missing a word here, set. Good. We have set, and in the backward arrow, this is a calculation. So a processing statement. We have a variable, and a constant, right? Okay, so this is a processing. Oops, processing. All right, and then this is a print with no read. So this is an obvious output. Now, good. And then we have our stop algorithm. So these are the statements we're going to be testing to see if it works in our trace table. Okay, let's look at our instructions here. Number one, draw a table with all the variable names as the table headings. Now, where am I going to get these variable names from? Let's look at our pseudocode. Our pseudocode in storage, wow, it has our variable names here. Great. So we see we have 1, 2, 3. Oops, I have a space here. That's bad. Right, so 3. We have 3 variable names. So we need a table with 3 variable names as the table heading. So that is our columns, right? We need 3 columns. Now, the last table heading is called output. So that's another column, right? Another column that we need here. Now, this output column you might not see in exams, all right? And that's okay. The program will still work. It means you are just going to use the variable ones alone. All right, anyways, so we have 3 variable names and a column output. So let's draw a table. I have my trace table here. I need, what did I say, 4? 4 columns. There we go. And I need to write in the variable name. So I have name. Oops. You need to write it exactly as the variable has it, following variable rules. Okay, no space there. And the last column is output. So that is step 1 and step 2. Good. So we've started our trace table. Step 3. Every time you see a print or an output statement, the information is written under the output table heading. Now, I want to mention something here. You will see print here, and that is our prompt statement. Yes, however, there's the word print. So technically, this is an output statement. So prompts are technically output statements. All right, so every time you see a print, I have 3 of them here, which is an output statement. The information is written under the output table heading, so that is here. Okay, since these statements will appear on the monitor to the user, so anything we write here is that connection, that link to the user, all right, as we explained. So this is the only thing the user is going to be seeing. And that's why the output column is so important. At the same time, in exams just want to see that your program is working. the data is working. So they don't necessarily have the output column. Anyways, we have the output column because we recognize it is important, right? I just want to move around my lines a little bit, give myself some more room. There we go. Okay, now, so that's step 3. This is just for future. Right, step 4. Look at the input statements and make up real data values for those inputs. Look at the input statements. So input statements I know would be a read statement. Okay, and I have one, two. I have two reads, therefore I have two input statements, which I already identified. Okay, and make up real data values for those inputs. All right, so let's see. Read name. Let's just make up a name here. Me. Right? We're gonna have me. Okay. Yeah, with two A's. Yes, good. Made up a name. And age. Let's see. May is 16. Right? All right. So let's put that down here. Input make up values. We have name equal me, and we have age equals 16. All right. So that was number 4. Look at the input statements, read, and make up the real data values for that input. Good, we did that, right? Now go through the program line by line, changing values in the table under the relevant variable table headings. Now, if you remember what a variable is, right? These are the variable names. What is a variable? A variable is storage. A variable holds a value, stores a value, right? So these variable names are just representative of a value that's going to be stored. Now, where do these values come from? It comes from the user and from the program. And remember, we are testing what the program is, how the program is going to work, right? And we made up some values here, we made up some data. So we're going to test the program to see how it would work if someone, a user, was using our program. And of course, we're testing it to ensure that it works correctly. So as we are testing it, if there was anything wrong with the program, we should have seen the errors. Okay, now, number 5. Go through the program line by line, changing values in the table under the relevant variable table headings. Let's do that now. I just want to take out the notes, the red pen here. Those are my notes, my explanations to you all. Good, that's gone. All right, now, what's all this? Don't want any distractions. I'm just getting rid of all these extra things. All right, whew, that's a lot. Good. Are we starting over? All right, there we go. Now, we have our program, right? Our algorithm or pseudocode. We need to go through line by line. We start at the beginning of the program. Duh, at the start, right? So line 5. We're at line 5. Nothing to do here. This just says this is where our program starts. Okay, so let's go to line 6. Line 6 is a print statement. And we saw, according to the instruction 3, print goes under the output table heading. So I'm going to be writing something here. What am I going to be writing? Am I going to be writing this? No. That is the code. I'm not going to write the code. Remember, I'm going to write down what the user will see. The user isn't going to see my code. Now, if you notice in that statement, there are quotes. So, wherever you have quotes, anything in between those quotes is what the user will see. So, I'm going to take out print from here, and I'm going to take out the quotes as well. Because remember, it's anything in between the quotes the user is going to see. So this appears, what is your name, appears on the monitor, appears on the screen. Now, if you were a user and you saw this appear on the screen, what is your name? What would you do? wouldn't you type in the data? Wouldn't you type in an answer? So I'm going to type in an answer, and we already made up our data. I'm going to type in May. Oh, I need red. No, I need, right, there we go. Yeah, you would type in an answer as someone who sees what is your name pop up on the screen. I'm going to type in my name. Okay, so I typed it in. Good. That was number 6. Good. Now, what happens? Number 7. Number 7 says, or line 7 says, read name. Read is an input. If you remember what input gets data. Input gets data. So, read means to get data, and name is a variable name. So, whatever data is input, it's going to be stored in the variable name, which happens to be name. So number 7, line 7, is going to get the data, which is May, and store it under variable name May. Variable name, which is name. Right. Let me just, okay. There we go. And notice I'm putting it in line with what it did. All right. So that's line 7. Let's go to line 8. Line 8 is a print. That should be, a bell should be going off in your head there. Print. That means output table heading. I should be typing something here. Now let's look at it. Print. Enter your age in quotes. Remember, anything in quotes goes on the output. Anything in between the quotes. All right. And when I see this on a screen, what is the user going to do? They're going to type in a value. I already made up a value here, so I'm going to type that in. 16. Good. So that was number 8. Now number 9. Line 9 says to read age. Input. I'm going to get the data and store it in my variable name. So let me get 16. Is that in line? Kinda. Alright. So 16 is now stored in age as the program says. Remember, we are following line by line, and we need, the devil is in the details, right? We need to look at what it says and we need to follow from that. We're not going to make up things in our head. We're not going to jump ahead. We're not going to rush. Rushing leads to errors. All right, so we'll finish line 9. Read age. Good. Let's go to line 10. Line 10. Set future age equal to age plus 10. Whew, that's a mouthful. Now, this is a processing statement. It says I'm going to set means I'm going to store this calculation under the variable name future age. So I'm going to do something here in future age. Let me go to the next line. Future age, what am I doing? I am going to store age plus 10. Now, I can't add words, but they don't mean the words. They mean the variable name. What is the value stored in that variable name? The value is, if we look here, 16. Now, 10 is not a variable, but 10 is a constant. So if I go to my constants, I will see what the value is. Okay, and now I need to cross this off. Good. And now I have 16 plus 10, right? And what is my answer? 26. Cross this off. Good. Now I have only one thing stored in my variable, okay? Because that's the rule of a variable. The rule of the variable is that only one data value can be stored in the variable at one time. So every time I showed my working, right? I showed my calculation. I input my I exchanged it with the values, and then I had my actual answer. So I showed my working, but I just crossed it off. And make sure that you show your working, but you can cross it off. Don't scratch it off. I need to be able to read what your working was. Okay. All right. So we have our answer 26. We're done with line 10. Nice. Let's go to line 11. Line 11 is a print. Come on, a bell should be going off. We have to write it under the output table. So we're going over here. Oops, I'm going on to the next line. Don't want to do that. Okay, let me just move that over a little bit. Everything shifted. Anyways, this is the line we're looking at, right? Line E10. Let me just put it back. We did line 10. We're on to line 11, right? Line 11 is this print here. Okay. So print in 10 years, you will most likely be working since you will be close quotes, comma, future age, comma, open quotes, years old, close quotes. Now remember I said we're looking at details. Now future age we know is a variable, right? And variables should not be in quotes. Variables should not be in quotes. That's why there's this comma here. The comma is separating the quotes from the variable. So we have a start quote and an end quote, right? Then we have a comma for variable name, comma, start quote and end quote. Now, print, ding, 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 come on. We're going into output statements here, output column. And we know that anything in between the quotes has to be written there. Okay, let me just move that around now. Right. So anything in between the quotes, in between, has to be written here. So in 10 years, you most likely be working since you will be, and then I have future age. Now, future age is not in quotes, so I am not going to be typing writing future age here. No, future age is the variable name that stores a value, so I am going to write the value. All right, whatever is stored in future age. Now it continues, years old inside of quotes, so that, oops, let's put D. That is what's going to show up there. And what's the next line? Stop algorithm. We are done. This is our trace table. Right, I hope that's helpful. And I look forward to seeing your trace tables, your perfect trace tables.